Assalamu alaikum. How are you guys? I hope you are all in a good health. Last lesson we talked about Rutherford's model and Bohr's model. Now we will continue from Bohr's model for hydrogen. As you can see, it says Bohr explained the atomic spectra by saying electrons move from one energy level to another when they absorb or emit photons. And like Rutherford, Bohr stated that electrons have circular orbits around the nucleus. To understand it better, you can see this demonstration here. It shows us how an electron gains energy here. As it gained energy, it jumped to a higher state. This state is called as excited state. But after a while, this electron starts to emit that extra energy that it gained and gets back to its lower state, its own original state. Now, when it gains energy, it jumps to high state. After a while, it loses that energy and returns back to its lower state. That was what Bohr was saying about electrons. Now here we have some notes. Notes 1 says if an electron is excited, it means absorbed a photon. The electron could jump into a lower state of energy by emitting a photon. And it's called a spontaneous emission. Spontaneous emission means normal emission. It does that without any external effect. So every electron wants to get rid of that extra energy that it has to return back to its original state. Second one says if a photon is absorbed by atom, the electron jumps to a higher energy level. As we saw before, here the electron absorbed energy and it jumped to a higher state because of that extra energy, but after a while it loses that extra energy because it wants to return back to its original position. After losing that energy, it returns back to its original energy state. Third one says the lowest energy level is the orbit with the smallest radius, and it's called as ground state in Bohr model. The radius of orbit is called Bohr radius. To understand these 2 points, you have to look at this figure. Figure 8.14. As you can see, we have an atom with 3 energy levels for electron. When an electron, we said, absorbs energy, it jumps to a higher state, and when it emits that energy, photon, it returns back to its ground state. And Bohr named those states. For example, this state, the smallest radius, with the smallest radius, this state, it's called as Bohr radius. It is the state in an atom with the smallest radius. It's called as Bohr radius. And this state, which an electron jumps when gains energy, when it absorbs photon, it's called as excited state. So Bohr named the larger state, excited state, the smallest state as Bohr radius and ground state. So for smallest energy state, we have 2 names: ground state or Bohr radius. But the other state we call it as excited state. Those were the names that Bohr used in his model. We can use this rule to determine the energy for an electron to jump from one state to another. We have energy in total is equal to initial energy minus final energy, and that energy as a whole is equal to HF. So the amount of energy that's needed for an electron to jump from one state to another is equal to hf. So if an electron wants to jump from here to here, or if we want to make an electron jump from this state to the excited state, we need amount of energy which is equal to hf. The fifth note says the electric charge between positive proton and negative electron is the force that holds electron in an orbit. So if an electron, in order to be situated in this orbit, we need positive proton electric charge and negative electron electric charge will be the force that holds the electron in those states. If those electric charge were not enough, electron could jump from one state to another, or even could be free from the force of the atom. Thank you for listening.